Assalamu alaikum, dear students. Today we will solve a very simple problem related to electric field. I will read it for you first. Two charges of magnitude positive 4 microcoulomb and negative 3 microcoulomb are separated by 50 centimeters. Find the electric field E at a point between them that is 10 centimeters from the positive charge. So let us have a simple sketch in order we see it better. We have Q1 here, which is of magnitude 4 microcoulomb, and away of it here we have a Q2 negative 3 microcoulomb. They are separated with or by 50 centimeter. Okay, we are interested in the location that is 10 centimeter from the positive charge. So 10 centimeter from the positive charge, which is a Q1. Here is my point P. It's 10 centimeter that I want to find the net electric field in. Okay, so I want to find the electric field at this point P that is 10 centimeter from the positive charge. If all the distance here is 50 and this is 10, then P is 40 centimeter away from Q2. To find the electric field, I apply the following formula. E equals KQ divided by separation squared. Now, at point P, the field is due to Q1 and Q2. If I want to find the direction of the field, I imagine that I have a positive, small, tiny, imaginary test charge here. What will happen to this positive charge due to Q1? Both are positive, so it will be repelled. So this arrow represents E1. And if this positive charge is placed at point P, it will be attracted to Q2. So also it will be in this way, E2. So I have the two electric fields pointing in the same direction. How do I know it again? I place a positive test charge at the point. And I see what will happen to it due to Q1, repulsion. What will happen to it due to Q2, attraction. And these are E2, A1 and E2. I will start applying the formula. E1 equals KQ1 divided by R1 squared, the separation. K is 9 times 10 to the power of 9. Q1 is 4 times 10 to the power of negative 6 to convert from microcoulomb to coulomb. The distance between P and Q1 is 0.1 meters squared. If you do the calculation, you can pause and check with your calculator. E1 will be 3.6 times 10 to the power of 6 Newton per coulomb. Similarly, E2 equals KQ2 divided by R2 squared. It's 9 times 10 to the power of 9 times 3. I ignore the negative sign as we said. We are calculating magnitudes now. Divided by 0.4 squared. This will give me around 1.7 after rounding times 10 to the power of 5 Newton per coulomb. Okay, now both are pointing in the same direction as we can see here. So E total will be E1 plus E2. If they were pointing in opposite direction, then you must subtract them. But here, since they are in the same direction, we will simply add them. It's a simple calculation that you can do using your calculators. Okay, the total will be 3.77 times 10 to the power of 6 Newton per coulomb. Since it's a vector quantity, you need to state the direction. Let us say pointing or toward the negative 3 microcoulomb charge. I hope that it's easy and clear. If you have any question, please you can ask.